So today we're doing electrochemistry. See, electrochemistry is something that I personally struggle with. So all I gotta say is focus up, watch the recording, and learn with Mr. Chin because he's the GOAT.
Okay, guys, first, let's look at electrolysis. Okay, guys, again, what is electrolysis, right? Okay, so we are converting electrical energy into a chemical energy, remember? Okay, what are we converting? Electrical energy to chemical energy. So you have done electrolysis, right? In IGCSE, it's the same thing. Okay, IGCSE electrochem. Okay, so in electrolytic cell, we have electrolyte, right? So we have an electrolyte which is molten or aqueous ionic compound, correct? So guys, we also have electrode, right? So made from either a graphite or metal, so to conduct electricity. All right, guys, remember, yeah, in electrolysis, anode is the what terminal, guys? Positive. Well done. Cathode is the negative terminal. All right, next, the power supply must be direct current, yeah. No, must be direct current. Okay, during electrolysis, cation move to cathode and ion move to anode. Okay, this is easy, right? Positive. Yeah, positive. Okay, nice. Guys, let's look at crowd. C-R-A-O. The first formula that you need to know is crowd. You guys done it in IG also. Guys, what crowd stand for? Go. What the hell is crowd? No, man? What's crowd? Gas, cathode. Anode. Cathode always undergo reduction. Remember, yeah? Anode always undergo oxidation. Okay, so guys, remember crowd. The first formula, I'm going to introduce a few formula. First one, crowd. Remember this, crowd. Cathode always undergo reduction. Anode always undergo oxidation. Crowd, crowd, crowd. Okay, so gain of electron is reduction. Reduction always happens in cathode. Oxidation always happens in anode. Alright, cathode always gain electron. Anode always loses electron. Yeah. I say, hey. Alright, guys, example, a molten sodium chloride electrolysis.
Also, in this set, you got an OF base. I mean, yeah, but it's not nice to say to someone.
So smash.
Ooh, that's smash. Well, what's all that about? They say, oh, your face, I kind of have like an OF face.
Okay, guys, example, this is a molten NaCl. Hey, sodium, okay, molten NaCl, let's go. Yes. What? Uh,
Power supply must be long.
DC.
Huh?
DC, direct current. Keep my notes to put this diagram in at least the next time people need to. Alright, guys, next, give me your cathode and anode equation and overall equation now. Cathode equation, discharge what? Anode equation, discharge what? Overall equation, discharge what? Go. No, I just changing it for the. Okay, guys, get your anode and cathode equation for me, yeah. Okay, guys, what is my anode equation? Cathode equation is sodium is gonna get discharged. So Na plus E minus turns into Na, right? Anode got discharged. 2Cl minus turns into Cl2 plus 2E minus, right? Overall equation. So this has to be multiplied by 2. So it's going to be 2Na plus 2Cl minus turns into 2Na plus Cl2, right? Alright, guys. Overall equation, you just have to balance the electrons and add them up. Yeah, done. Alright, guys, next. Okay, you see, right? In a molten electrode, in molten electrolyte, guys, molten electrolyte example, you have AgBr liquid. Okay, so guys, what to select? You just have to select the cation, discharge it, anion, discharge it. So again, Ag is formed, right? Ag plus E turns into Ag. That's your cathode equation, right? Anode equation? How? 2Br minus turns into Br2 plus 2E, right? That's it. So for molten, right, you just have to discharge the ion immediately. Done. Reduction is gaining electron. Alright, guys, next. Okay, the moment you see the word aqueous here, okay, if you see aqueous is different story now. So aqueous, right, it contains a H plus and OH minus.
I said, don't slide.
Okay, so again, aqueous, right, contains NaH plus and OH minus. Okay, example, guys, aqueous solution of sodium chloride contains this amount, okay, this amount of ion, yeah, Na plus, Cl minus, H plus, OH minus. Alright, guys, where your H plus and OH minus is from, right, is from H2O dissociate to form H plus, OH minus, right? Okay, done. Okay, guys, among the other things, right, it depends on two things, the concentration of your electrolyte and also metal ion. Okay, I'll talk about it later on. Alright, guys, done. Next, I want you guys to look at this value. Yes, up. Can. Done. Alright, guys, electrolysis. Electron potential value. Alright guys, this is your standard electrode potential value. Okay, so basically you have two tables. Okay, yeah, you can still refer to the data booklet, but right now, if any value is needed, it will be given. So you don't have to memorize any of it, but you just have to know how to use this value. Alright guys, you see, you have two tables. One of it is arranged in alphabetically order. Another is arranged in the magnitude of the value. Okay, so basically the same thing. I just have to choose one to refer to. All right, so guys, you have all these, for example, Ag plus E turn into Ag, okay, or Ag turns back into Ag plus E, or Li plus E turn into Li, at the same time, Li can turns back to Li plus E. Okay, like NO3 turns into HNO2, or HNO2 turn back into NO3. Okay, everything can be simplified with an electrode potential value. So guys, I'm gonna give you the most godlike formula that you really have to memorize through. Okay, you just have to apply this formula, right? Okay, this entire chapter is done. That's it. So the very godlike formula is PRR. Okay, this is my super godlike formula. Okay, so PRR. Okay, I'm gonna use it all the time when we are doing past paper. I'm just gonna mention PRR. The entire thing must stuck in your brain. PRR, PRR, PRR. So what PRR stand for? Whenever you are looking at a positive electrode potential value, the direction of equilibrium will always go to the right, and the substance will always undergo reduction. I'm putting some trash food again. Oh, no lah, I grab food, you just collect order from me, bro.
How many sauce?
Sauce, yes, exactly. Yeah, but I need protein.
Your other two?
Yeah. Okay, so again, guys, when the value is a positive value, the direction of equilibrium will always go to the right, and it's always undergoing a reduction. So which means, guys, you see, let's look at the value. Do you see this value is positive? Which means this is a PRR, right? Which means the direction of equilibrium will go to the right. Understand? Which means Ag plus will turn into Ag by undergo a reduction. Clear? So this is a reduction reaction. Guys, when you see a negative value, what happens? This is opposite of PRR. Guys, what is opposite of PRR? Negative will go to the left and it undergo oxidation. Understand? Okay, no, not bad. Negative oxidation, left, null. Yeah, null. Okay, good job. Null. Null. Yeah, not bad. Yeah, so guys, remember PRR, positive right reduction. That's it. Simple as that. Okay. Okay, at cathode, the ease of discharge, right? It depends on your electrode potential value. Okay, highlight. The more positive E value will be reduced. Highlight the word. More positive value will be reduced.
Electrode or electrode?
Electrode. My R is missing.
This actually point.
Example, if you have a H plus and Na plus, we always choose the more positive value. Do you see that this value is more positive? So it undergo reduction. Right. I need some fruits, or else I cannot shit. Alright guys, next. At anode, the ease of discharge, right? Based on a few factors, based on the concentration of the electrolyte. So highlight the word. If the electrolyte is dilute or concentration not mentioned, always choose OH minus. Okay, so OH minus is oxidized into oxygen. The equation is 4OH minus turns into O2 plus 2H2O plus 4E. And guys, all the complex ion, yeah, like sulfate, phosphate, okay, nitrate are never discharged. Remember, yeah, complex ion are never, ever, ever, never discharged, please. Guys, take this, take a screenshot. This, go and copy it at home. Yes, quite.
Okay.
Okay, so guys, this you can copy at home. Alright, guys, with that said, that'll be all for the class today. Okay, I'll see you guys next week. Voted option 1, right? Okay, yeah. Open up page 7, kid. Let's continue with page 7, electrochem. Okay, the mass of a substance produced during what happened to your best buddy? Okay, so the mass produced, right, is proportional to the time over which the current passes and the strength of your electric current. So the first formula that we have is Q equals to IT. Okay, guys, what Q stand for? Q is basically the charge that we are supplying.
I is current.
Yes, I is current, right? I is current, always in ampere. T is time, always in second.
Yeah, we always say it.
Yeah, this chapter is physics. Alright, guys, next. So what the quantity of electricity is expressed in terms of a unit known as Faraday. Okay, in physics, we have your Faraday constant. Okay, so 1 Faraday, right, is the electricity carried by 1 mole of electrons. Alright, so guys, the value for Faraday is 96,500 coulomb per mole.
So now next week's our trials.
Yeah. GG. How's your prep?
Chill, yeah.
Chill, yeah.
House.
Alright, guys, first formula. I have Q equals to NF. Okay, I want you guys to write it down. Q equals to NF. Q is the charge. And guys, N stands for the number of electrons. Sorry, number of mole of electrons. F is your Faraday. 96,500. Okay. Guys, I can have a second formula. Q equals to NE. Q equals to Ne.
Why the fuck all the physics formula coming lah?
Well, I don't know, man. Okay, so guys, what N stand for? This time, right, if you use Ne, it's gonna be a number of electrons. Well done. E is the charge of 1 electron, right? A constant, right? Which is 6 times 10 to the power of negative 19 coulomb. Alright, guys, you see, right? During electrolysis of a silver nitrate solution, silver is deposited at the cathode. Okay, so I have Ag plus, then plus E minus turned into Ag. Okay, now, 1 mole of silver is formed. How many mole of electrons are needed?
Thank you, Johnny.
I think it's yourself now.
Hey, Johnny, you want water?
What the hell? Why your pants is all wet? What the heck? Okay. So Ag plus E minus turn into Ag. So guys, you see, right? In order for you to form 1 mole of silver, you also need 1 mole of electrons, right? Correct. So guys, what is the total charge required to discharge 1 mole of electrons? So 1 mole of electron carry, so you can use the formula Q equals to NF, right? Which is 1 mole of electrons multiplied by 96,500. 96,500 coulomb. Understand? Okay guys, question 5.
Yeah. Can as well.
Time as well.
Inside your mom,
Sorry?
central
She's with Darren and Jason.
yeah, I think your mom.
No.
Alright guys, next. This question now. Let's say, right, if I have 2 mole of copper, how many mole of electrons needed? So 1 mole of needed electrons, 1 mole of copper needs 2 mole of electrons, right? 2 mole of copper needs 4 mole of electron. That's it. What's the total charge required? So Q equals to NF. How much? 386,000 coulomb, right? That's it. Huh? Chapter 22. Alright guys, next. To find a mole of substance liberated, we have this formula. The mole of substance formed equals to Qs over Qr. Okay, what is Qs, right? That's our supplied current.
This is a grass.
Formula is IT, correct? QR, that's the charge required. NF, or Ne. That's it.
That's all.
Yeah.
I hear what's that song called stereo?
Stereoisomer.
Bird. You know? The bird.
Okay. Okay, guys, page 8. Let's go.
The bird. The bird.
Alright, guys, now, in the exam, right, they might want you to calculate the mass of copper or mass of metal form, right? Okay, guys, I'm going to give you a 4-step hack. First step, please find out your charge supply equals to IT. Second, I want you guys to write down the half equation and find QR. NF or Ne, depending on which formula is needed, yeah? Third step, 5 mole. QS over QR.
Face wash. Salmon is what? Hungry salmon.
5 mass. Mole times MR.
Film.
So you think he cute? How dare you say that? Get out.
I agree with you.
Watch your mouth.
Why? She's your who?
No lah.
Then,
Soon to be girl.
huh, really?
He just like Malay girls.
Bro, just shut up, bro. Shit off my dick. It's okay.
Bro, why he sound like angry mom? um, no.
Me?
No.
Did he say a Chinese name?
No.
Get out, bro. Don't fucking sound Chinese.
Alright, guys, now done. Let's look at the question. We're gonna do it together. Alright, copper is extracted by electrolysis. Okay, passing current of 2 amp for 2 hours. Calculate how many grams of copper is formed. Okay, guys, first step. What's my QS? Go. Charge supply is IT, right? Current 2, time 2 hours, each hour 3,600. Final answer 14,400 coulomb. Correct. That's your first step.
Okay.
Ryan,
Right. Right.
the boyfriend.
What change was that? Why have one when you have two? Oh no.
Second step.
What's that shit?
Right half equation, guys. How do you form copper? The half equation is Cu2 plus 2 electrons turn into Cu, right? Guys, what is my QR? And F, right? So number of mole is going to be 2 times Faraday, right?
Oh,
193,000, right? Done. Equals to QS over QR, right? Let's go. QS is supplied 14,400. Required how much? 193K, right? Press your calculator. How much is it? So you get the mole already, right? Last step. Last step is mass equals to mole multiplied by MR. 0.0746. Your MR of copper is 63.55. Your final answer 4.74. Is that right? Done. Clear. Right, next question. Let's go. 10 grams of magnesium in 4 hours. Let's do it. Okay, guys. For this question, right, you're gonna work backwards. So your step is 4, 3, 2, 1. Now, try it out now. For this question, they want you to find the current. Okay, it's given the mass of magnesium is 10 grams. So you're gonna work backwards now, guys. Work backwards. So do 4. No, sorry. Go this way. 4, 2, 3, 1. Go. No, sorry. 4, 2, 3, 1. Correct. Go. Step 4 first. Step 2 second. 3, 1. Go. Now, let's do it. Okay, guys, let's go. What's the current required to deposit 10 grams of Mg in 4 hours? No one. Anyone? 5.52 Okay, thank you so much. Thank you. Okay, now let's go. So first part, I want to find the mole first. 10 gram divided by 24.3. 0.412, right? Okay. Everyone got 5.5, 5.6, can. Second start. Mg2 plus. 2E minus. Mg, correct. Two times 96,500, 193,000 coulomb, correct. The start. Mole multiplied by your QR, that will be your charge supply. That will be what? 79,516. Last step. Charge divided by time. Divided by 4 hours, each hour 3,600 seconds, 5.5 amp. Is that right? Hello, guys. Done, Okay, guys. Let's flip all the way to page 19. Page 18 now. Let's go. Page 18, we're going to do Avogadro's constant. Alright, so guys, how do you calculate Avogadro's constant? We have a formula, we call it as LFE. Okay, so right now, write it down. L equals to F over E. Okay, so Avogadro's constant, 6.02 times 10 to the power of 23. Faraday, 96,500. E, oh my god. Charge of 1 electron. Okay, in exam, right? Okay, this value, right, you have to prove in exam, yeah? Okay, so you have to prove the value in exam. Don't sub in, don't just write it down, you have to prove it. So sometimes they ask you to prove F, sometimes they ask you to prove L, sometimes they ask you to prove E. So it depends on what is given to you. All good. So the results show that the charge of 1 electron is approximate 1.6 times 10 to the power negative 19. Okay, first step, guys. I want you guys to find QS and QR. That's your first step. Find QS and QR. Second step, I want you guys to find the value of F. So QR equals to NF. QR divided by N. Last, L equals to F over E. You have to find L or find E. or find F. Constant of 0. If this amount of copper is formed. Okay, 34 minutes. Charge is given. Alright guys, I'm going to give you a step. I want you guys to do it. First, can you find a QS? Second, can you find a mole of copper? Next, can you find a QR? Go. So do this first. QS, how much? Mole, how much? Charge supplied, charge required, how much? Go. See, I have you to start the conversation.
Not bad. They will be these.
Alright guys, let's go. QS equals to 34 times 60, right? How much? 408 coulomb, right? Second, guys, what's the mole of copper? Mole of copper is 0.13 divided by 63.5, right? Oi.
I said girlies lah. Do you know what girlies is or not?
You think how you can see more lah?
That's fucked up, bro. No, one.
Okay, so mole done. Next, QR. QS, okay, QR equals to mole, sorry, QS divided by mole, right? Go. How much? 199K, 292 coulomb, right? That's it. Next. Done. Your QS 199, 292, guys. Next. Find F. So I know that Cu2 plus 2E. So guys, I know that QR equals to NF. Okay, I do know the value of F, but you cannot just write it as 96,500. You have to prove it. So F is equals to 199,292 divided by 2, right? 99,646, right? Okay, last. F over E. I'm getting around 6.2, right? That's it. Please check your answer. We are moving on to page 20. Yeah, it's okay. When you are proving, right, your F, right, and your L might not be the actual value. It will be slightly more or slightly lesser. It's okay. Yeah, slightly more or slightly less is okay. Okay, just don't use, if you never prove, guys, you're not getting the marks here, yeah. So please, you have to find the value. Find the value. Okay, I know you know that your F is 96,500. Your Avogadro's is 6.02, but you have to prove it. Okay, but when you're proving it, right, it might not be exactly the same, but it's okay. Page 20. Alright, now let's look at electrode potential, E naught value. Alright guys, again, for any unreactive matter, right, your direction of arrow always goes to the right. Okay, now this is the most important formula in this chapter. We call it as PR. Where's that?
Equal.
Ipo. Okay, so guys, what PR stand for? When the value is a positive value, direction of equilibrium always shift to the right, and the substance always undergo reduction. Remember, yeah, this is the most godlike formula, yeah. Alright guys, but for reactive matter, right, the value will be a negative, so it goes to the left. So it's just opposite of PR. What PR? Positive right reduction. But when it's oxidation, then it goes to the left. So what if the examiner decided to flip the equation? No, the equation is given as a standard value in your data booklet, so it won't be flipped. Even if it flipped, it's still okay. The value will still be the same. Because you see, all this value is given as, okay, all the equation is given here, and there's a value. Okay, if you flip, right, the PRR will still apply. So the PRR is the most, okay, this is the most godlike formula in this chapter. You just have to memorize PRR, positive right reduction. So if you look at any of the value, as long as it's positive, direction of equilibrium is always to the right. If it's negative, direction of equilibrium to the left. That's it, simple as that. Okay, and when it goes to the right, always undergo reduction. Okay. Alright guys, let's continue. So we can measure the difference in potential, right? Okay, between another system. Okay, point 4, can skip it. We call it as electrode potential. And the system we use to compare, we call it as a standard hydrogen potential. So I'm going to talk about your standard hydrogen potential now. Alright guys, this is how we draw our standard hydrogen potential. So basically you have an inverted gas jar with an opening here, and you're supplying hydrogen at 1 atm. Electrode must be platinum. Concentration of H plus must be 1 mole per dm cube. That's it. Okay, so guys, later we're gonna draw. Okay, we're gonna start drawing it. So first, let's look at your hydrogen standard first. Guys, for your hydrogen standard, yeah, whenever you are drawing it, later draw. First thing, your concentration of H plus must be at 1 mole per dm cube. Must. Second, pressure must be at 1 atm. Temperature must be at 298 Kelvin. And you must always use a platinum electrode. Okay, now, not platinum black. Ow! Scrub up, come on, come.
Yeah, I know. That's the first thing I told you. Very nice, right?
Hey guys, let's continue. You see, right? Okay. In exam, I don't understand the electrode potential. Which one? This one. What does it mean by another system? Oh, so it's connected. This is just 50% of it because it will be connected to another system. Okay, later I will show you a diagram. Okay. So usually, right, when you connect it, it's always like that. Okay, it's always like one system on the left, another system on the right. So a standard hydrogen, which means one side must be with a H2 1 atm, H plus 1 mole per dm cube, and platinum. Okay, so we're gonna do it later. All right, guys, now let's look at standard electrode potential. Shh. So, guys, the definition is potential difference. Okay, when a half cell is connected to a standard hydrogen electrode under standard condition. The ready black. Who is ready black?
What you don't talk about porn, bro? I literally said Muslim. What the fuck?
You guys are so weird. Electron potential and the redox reaction. Alright, guys. Remember, my study tip is PRR. When the value is positive, direction always go to the right and always undergo reduction. Remember this, yeah, please. So by convention, the electron potential always refer to a reduction reaction.
Oh.
Alright, guys, now I want you guys to look at this value. Okay, do you see the value that we have? Your E naught is a positive value. So do you see this is PRR? Which means the direction will shift right. The direction will shift to the right, right? So guys, when the direction shift to the right, Ag plus will undergo reduction. And forms Ag, correct. So guys, can Ag form back Ag plus? Yes or no? No. Because again, according to PRR, positive right reduction. So Ag hardly turns back. Okay, I can say that Ag hardly oxidize to form Ag plus, right? Which means Ag is a weak what agent? Go, please tell me now.
But okay.
Well done. Because Ag hardly oxidize, which means they are a weak reducing agent. Lovely. Right, because according to PRR, positive will always undergo reduction. And right. No worries. Clear. So guys, you see, right? The more positive the value, the easier it is to undergo reduction, right? Hence, metal on the right is unlikely to react, and it's a poor reducing agent. Alright, guys. Now, let's look at this value, guys. So, do you see a negative value here? Which means it's opposite of PRR, right? So guys, please tell me where the direction will go now. Direction will shift to where? To the left, right? Which means Al will undergo what? Okay, positive is reduction, negative is oxidation, right? And forming Al3 plus, correct? So guys, which means Al is a good or bad oxidizing or reducing agent? Please tell me now. Are they good or bad? Now, I put it as good what agent? Well done. Which means they are good reducing agent because they undergo oxidation. Well done. Dana, page 22. Go.
Next week.
Alright guys, now let's look at the position of equilibrium. So guys, your PRR, right, might get affected by two factors only. The first factor is changing concentration of your electrolyte. The second one is change in temperature. Oh. What about your standard condition? Pressure must be at 1 atm. Oh my god.
Before you start, it should be this.
Oh.
My coffee.
Oh, that one.
Yeah.
Coastal is one.
Yeah.
Alright, temperature 298 Kelvin, right?
Coffee.
Concentration of electrolyte. Must be 1 mole per dmq, right? Next, your half cell must be connected to what? A standard hydrogen electrode, yeah. Under this condition, the electrode potential we measure is called standard electrode potential, right? Alright guys, next we have standard electrode potential of a half cell. What's the definition? It's the same thing, right? Is the potential difference when a half cell is connected to standard hydrogen potential the electrode under standard condition. Why? You can smile, man. You can smile to the camera, say hi, I'm Chantel. 哎，谢谢，拜拜，再见。Alright, guys, let's look at draw a diagram to show a standard sodium electrode. So for a standard, right, one side must be connected to hydrogen. Yeah, let's draw the hydrogen side first. That sounds safe. Why? What happened?
Why you can wrap it? Wait, why you just wait, try to
So skinny.
other probably. Go look at me.
All right, guys, you see, right? We are sending in. Wait, do you not use NAS method? Yes, we do, but I'm drawing the standard hydrogen first. Okay, 1 atm of hydrogen gas. I need a PT electrode. And I need the concentration to be in 1 mole per dm cube of H plus. Okay, that is my standard, yeah. Draw it out now. All right, guys, another side. Draw your hydrogen. Sorry, draw your sodium here. Connected to a sodium electrode. One mole per dm cube of Na plus. And guys, do not forget the presence of a salt bridge. So you have to draw a salt bridge. That's it. Right, guys, that's how we draw it, huh? Go, go.
So on you.
Right, guys. Right now you're starting to keep closer. Yeah, give me a second. I go with my water. Go, go. There. Huh?
How is that now?
Yeah, it's fine.
All right, guys, again, temperature must be 298, pressure must be 1 atm, concentration must always be 1. And guys, don't forget your salt bridge, electrode. So we have 3 types. If it's hydrogen style, use platinum and 1 mole per dm cube. Yeah? So for your metal half cell, metal electrode, then 1 mole per dm cube of electrolyte. Non-metal, you use platinum and 1 mole per dm cube of your anion. That's it. All right, guys, now let's look at measuring standard electrode potential. All right, good. You see, we have 3 different types. The first one is half cell containing a metal and metal ion. So, example, guys, we are measuring Cu and metal ion. So, the electrode must be copper metal, electrolyte Cu2 plus. Okay. Okay, guys, now I'm going to give you 3 formula to remember. All right, you need to memorize this here. PRR, second formula, Crown, third one, AC. Okay, these 3 formula, go and memorize it, please. All right, guys, we have done PRR, we have done Crown. Next, what's AC? So the electron always flow from anode to cathode. We want to say hi to. Okay. So guys, now I want you guys to identify where is the direction of electron flow here. Go. Identify the direction of electron flow now. Give me a second. I forgot to mark attendance. Let me mark it now. So again, let's look at the value. You see, this value is more positive, right? Which means this is my PRR, correct? So guys, let's say this is the PRR, which means according to PRR and crowd, this is also cathode, right? Because cathode will undergo reduction. So I know this is my cathode. This is my anode. Direction of electron flow is going to be like that. Done. Clear? Okay, so plus is always your cathode.
You guys.
And hydrogen is the anode, right? That's it. So the E values show us that CO2 plus are easier to reduce. They have a more positive E naught value. So CO2 plus is more likely to reduce, right? That's it. All right, guys, why do we need a salt bridge? So guys, first reason is for movement of ions. Second reason is to balance the charge. And also the acidity or the alkalinity of the electrolyte. Done? Okay, page 24, let's go. All right, guys, half cell containing a non-metal and non-metal ion. All right, guys, let's look at the study tip first. Okay, for a non-metal, okay, what do we need, right? We need a platinum electrode. Okay, remember, yeah, electrode must be platinum. We also need 1 atm dust. And see that the concentration, remember, must be 1 mole per dm cube. Alright, guys, for this diagram, I want you guys to identify where is my cathode and anode and the direction of electron flow. So again, you must use a platinum here. Yes. Alright, guys, now let's go. So again, why do we need platinum? Because platinum is inert, yeah. Which one is positive? This is more positive, right? So again, this is my PRR, which means it's also our cathode reduction, right? So this is my cathode. Anode, direction of electron flow going this way. Done. And okay, so show that Cl2 is easier to reduce because they have a more positive value of here. Yeah. Okay, done. Okay, guys, last part. You see, guys, the next one, right? We have multiple, okay, different oxidation state. So again, for different oxidation state, we also use platinum electron. And the concentration must always be 1 mole per dm cube. So guys, when this happens, right, remember, your electrode must be platinum. And all the aqueous ion must have 1 mole per dm cube. Okay, so all the aqueous ion present, right, the concentration must be 1 mole per dm cube. So guys, example, you see? Do you see aqueous ion? Do you see aqueous ion? So both are 1 mole per dm cube. Can see that? So guys, you see, let's say if I have this equation, all the aqueous ion must be 1 mole per dm cube. So I need 1 mole per dm cube of MnO4, 1 mole per dm cube of H plus, 1 mole per dm cube of Mn2 plus must be in 1 mole. So as long as they are aqueous ion, must be at 1 mole per dm cube. This is for multiple oxidation state, yeah. Let's go. Please write down. 9:30 and class over. Yeah. Yes. I have to go back. Okay, so guys, that will be all for the class today. I will see you guys next week.
Okay, so that's all for today's topic. So thanks for watching.
Please like and subscribe. So someone can take it.